Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help finish up your notes here on Module 16.5. So we're going to look at this problem where it says the percent of correct welds a student can make will increase with practice and can be approximated by the equation, which I've written down, P equals 100 times the quantity 1 minus 0.75 to the T, where P is the percent of correct welds and T is the number of weeks of practice. Find the percent of correct welds a student will make after 4 weeks of practice. So basically this problem boils down to they've given you a formula here. We are to try to calculate a value for P if this is 4 weeks. So this is just a matter of putting in the numerical value given. Go ahead and do that. And calculate a value. So let's see, 100 times the quantity 1 minus 0.75 to the fourth. And I get 68.4%. So after 4 weeks, it sounds like this person is doing this correctly 68.4% of the time. So that was a pretty short one. Please get it in your notes. I'm going to go ahead and in this same video here get the rest of your notes finished up here. So the next question, and I'm not going to write it out, you have your handouts here. It says the percent of light that will pass through a material is given by the equation. If you give me a moment, actually I can probably just leave this here for you. Shrink it down, move that over here. Okay, the percent of light that will pass through a material is given by the equation log P equals minus KD, where P is the percent of light passing through a given material. K is a constant that depends on the material, and this is all written in more detail in your handout. D is the thickness of the material. Okay. It says the constant K is 0.5. How thick a piece of glass is needed so that 60% of the light passes through it. So, all right. We're going to take this formula here, and what it is, we're going to try to solve this for D. So this is going to read log base P. Now, P is the percent. You typically write that as a decimal. And we want 60% of the light to go through. So log of 0.6 is equal to minus K, and K is 0.5 in this problem that was given, and times D. So now it's just a matter of solving this for D. Okay, and the first thing I'm going to do is type log of 0.6. I've got a strange calculator here and I'm having trouble finding the logarithm button. Just bear with me. There it is. So log of 0.6, if I put a numerical value there, is minus 0.221. Actually, to three figures there, it's actually 0.2218. I'm going to go ahead and just round that to a 2. And that's kind of a cool looking number anyway, right? 222 equals minus 0.5 times D. And then this is solved by dividing both sides by minus 0.5. And when we take 0.222 and divide it by 0.5, we get 0.444. I'm just going to say approximately 0.44. And D was in centimeters. So that one's pretty well done. Next one. It says use the Richter equation. M equals log of I over 10, where M is the magnitude of an earthquake, I is the intensity. All right, so let me take this work. I'll just scale it down. Okay. And now we'll start working on the next one. It says to use the Richter equation, which they have written down. M equals log of 1 over, oh, not 1 over 10, I'm sorry, I over 10, where M is called the magnitude of the earthquake, and then I is the intensity, meaning basically how many buildings came down. Let's see. How many times stronger in intensity is an earthquake that has a magnitude of 5.8 than one that has a magnitude of 3.2? So how many times stronger? So that's really a ratio. So what we're going to do is we're going to apply this formula twice. And before I even actually write the problem out, I'm going to take this and write it in exponential form because the intensity is what we want to calculate. So this means 10 to the m equals I. Now, that's because this is log and you don't see a number. If you don't see a number, it's assumed to be base 10. Or not just assumed. If you don't see a number, it is base 10. So I did 10 to this power equals this guy. Oops, and that's actually I over 10. Because 10 to the m equals whatever we have here. That would be I over 10. All right, so then if I solve that for the intensity, we get 10 times 10 to the m. So what I'm going to do now is just calculate some values here that were given in this problem. So we've got a 3.2 and a 5.8. So if the magnitude is 3.2, then the intensity is going to be 10 times 10 to the 3.2. I'm going to run a value here. Okay, and I get a numerical value here of 15,848, and actually 8.489. Let's just round that to a 9 there. Does it say anything about units? The intensity of shock wave isobo is constant. I don't see anything unit-wise. We'll just leave that alone then. We're not going to need it to actually answer the question. If the magnitude is 5.8, then the intensity is going to be 10 times 10 to the 5.8. If you want to just write that as 10 to the 6.8, that would be fine. And I get, whoa, big number here. I get 6309573. Okay. So now it says how many times more intense is this magnitude than this. So that's a ratio. So what we're going to want to do now is take this value and divide it by this value. And I get 400 times. So the ratio here, I'll write it like this. If I take the intensity at 5.8 and divide it by the intensity at 3.2, I get 398, or I'll just say approximately 400 times. So this earthquake here is apparently 400 times more intense than this one. All right, what else do we got on the handout? That's it. So this video here is meant to finish up your notes here under logs and exponentials. I'm going to make another video set here talking about your homework. Hope that this gets you through it. Have a great day.